Hello and welcome to my blog. Today, I am going to tell you the amazing story of the world's first computer, how it was invented, what it could do, and why it changed the world. The word computer comes from the Latin word computer, which means to calculate. For a long time, people used different tools and machines to help them with calculations, such as abacuses, slide rules, and mechanical calculators. But these devices were limited in their speed, accuracy, and functionality. The first person who dreamed of a more powerful and versatile machine was an English mathematician named Charles Babbage. In the early 1800s, he designed two machines that he called the difference engine and the analytical engine. The difference engine was a mechanical calculator that could perform simple arithmetic operations. The analytical engine was a much more ambitious project that aimed to create a general-purpose machine that could perform any kind of calculation using instructions stored on punched cards. Babbage never finished building his machines, but his ideas inspired many other inventors and scientists. One of them was Ada Lovelace, the daughter of the famous poet Lord Byron. She was fascinated by Babbage's analytical engine and wrote an algorithm for it in 1843. This algorithm was essentially the world's first ever computer program. She also predicted that such a machine could do more than just calculations, but also create music, art, and other forms of expression. However, it would take another century before the first electronic computers were built. The main challenge was to find a way to store and process information using electricity instead of mechanical parts. One of the pioneers in this field was a German engineer named Konrad Zuse. In 1938, he built the Z1, the world's first freely programmable binary-driven mechanical computer. It was a huge machine that filled his parents' living room and used thousands of metal plates and wires to perform calculations. It was programmable via punched tape or punched tape reader. Zuse continued to improve his machines and built the Z3 in 1941, which is considered the first fully functional electromechanical computer. It used relays, which are switches that are controlled by electric currents, to perform arithmetic and logical operations. It could also store up to 64 numbers in its memory. But Zuse was not the only one working on electronic computers during World War II. In fact, the war accelerated the development of computing technology as both sides needed faster and more reliable machines to perform complex tasks such as cryptography, ballistics, and code breaking. One of the most famous examples of wartime computers was ENIAC, which stands for Electronic Numerical Integrator and Computer. It was built by John Mauchly and J. Presper Eckert at the University of Pennsylvania in the United States between 1943 and 1945. It was funded by the U.S. Army and designed to calculate artillery firing tables for different weapons and conditions. ENIAC was a massive machine that occupied a 50 by 30 foot room and weighed 30 tons. It used about 18,000 vacuum tubes, which are electronic devices that can amplify or switch electric signals to perform calculations at an incredible speed for its time. It could execute up to 5,000 additions, 357 multiplications, or 38 divisions per second. ENIAC was also the first programmable general-purpose electronic digital computer. It could be reprogrammed to solve different kinds of problems by changing the wiring of its plug boards and switches. However, this process was very tedious and time-consuming, as it took days to rewire the machine for each new problem. ENIAC was completed in 1945 and first put to work for practical purposes on 10th December of that year. It was formally dedicated at the University of Pennsylvania on 15th February 1946 and called a giant brain by the press. It had a huge impact on science, engineering, and military applications. It also inspired many other computer projects and innovations in the following years. One of them was EDVAC, which stands for Electronic Discrete Variable Automatic Computer. It was also built by Mauchly and Eckert at the University of Pennsylvania with input from John von Neumann, a Hungarian-American mathematician who joined their team in 1944. EDVAC was designed to be an improved version of ENIAC that would use binary numbers instead of decimal numbers, store instructions in its memory instead of on plug boards, and use a simpler and more efficient logic design. EDVAC was one of the first computers to use what is now known as the von Neumann architecture, which is still the basis for most modern computers today. The von Neumann architecture consists of four main components: an input device, an output device, a central processing unit, CPU, which is the brain of the computer that executes the instructions and performs the calculations, and a memory unit, which is where the instructions and data are stored and accessed by the CPU. EDVAC was completed in 1951 and delivered to the U.S. Army's Ballistic Research Laboratory at Aberdeen Proving Ground in Maryland. It was one of the first computers to use magnetic tape as a storage medium, which allowed it to store much more information than ENIAC. It was also one of the first computers to use subroutines, which are sections of code that can be reused for different purposes. EDVAC was used for various scientific and military applications, such as calculating missile trajectories, nuclear physics, weather prediction, and cryptography. It was also used for educational purposes, as it was visited by many students and researchers who wanted to learn about the new technology. EDVAC was a milestone in the history of computing, as it demonstrated the power and potential of electronic digital computers. It also influenced many other computer projects and developments, such as EDSAC, UNIVAC, and IS Machine. But EDVAC was not the only computer that used the von Neumann architecture. In fact, there were many other computers that were built around the same time or shortly after EDVAC that followed the same principles. Some of them were even faster and more advanced than EDVAC. These computers are collectively known as the first generation of computers, which spanned from 1946 to 1959. The first generation of computers had some common characteristics, such as they used vacuum tubes as their main electronic components, which were fragile, bulky, and generated a lot of heat. They used binary numbers as their basic unit of information, which made them more efficient and accurate than decimal-based machines. They used machine language as their programming language, which was a low-level language that consisted of binary codes that corresponded to specific instructions for the CPU. They used punch cards or paper tape as their input and output devices, which were slow and prone to errors. They had limited memory capacity and speed, which restricted their functionality and performance. Despite these limitations, the first generation of computers made remarkable achievements and breakthroughs in various fields of science, engineering, business, and government. They also paved the way for the second generation of computers, which would use transistors instead of vacuum tubes, and introduce higher-level programming languages, such as Fortran and COBOL. In this video, I have told you the story of the world's first computer, how it was invented, what it could do, and why it changed the world. I hope you enjoyed it and learned something new. If you did, please like, share, and subscribe to my channel for more videos like this. Thank you for watching and see you next time.